Math 3, Unit 9, Section 3. Today we're talking about quadratic design problems. We're going to work backwards a little bit here. We're going to start at example 5. So this is our new example 1. Okay, so it's important to know how to read the information in the problem. Okay, so I'm hoping you guys are going to be able to do this. Kiana is standing on the ground. So we're going to look at this picture right here. Here is Kiana. She's over here on the ground. I know you guys are completely impressed with my drawing skills. I did take art in college. Okay. Obviously, I'm not sure what that grade was, but there you go. So Kiana, she's on the ground. Notice how she's sitting here on the ground, or standing, whichever you want her to be. And she throws a tennis ball. Okay? So she is throwing this tennis ball up. Okay? And if you notice, what kind of shape happens when you throw something? An arch. Like, and it is specifically called what?
A parabola.
Or?
A U. Quadratic.
Quadratic function. If you look, that was the title. Okay, so parabola. Anyways, so when you have a parabola, when you throw something up, it reaches a maximum height. Would you guys agree with that? And in terms of quadratic functions, what is that maximum value actually called?
A vertex.
Very good. Your vertex. Okay? So it's telling you that she throws it vertically upwards with an initial speed of 112 feet per second. Its height after t seconds is given by this equation. Notice that you have this 112 feet per second here, and notice this 112 in the problem. Okay? So the next thing, if we're talking about our graphs, is that the y-axis, the going up and down, this is the height of the ball. And then right and left, like your x-axis, this is your time. So when you find your vertex, and we know that our vertex is x comma y, do you guys agree? That really means that you have time comma height. So the x value is the time it takes. The y value is that maximum height that it's reaching. Okay? Do we have questions so far? Does this kind of make sense? Okay. So in order to find our vertex, we're going to go back to a previous unit. And we're going to take this equation and we're going to complete the square. Because if we complete the square, we will end up getting our vertex from the equation. Okay? One thing, though, that I notice about this equation is that it is not in descending order. So I'm going to rewrite it. So h equals negative 16t squared plus 112t. Now, when you're completing the square, you don't want a what? An a value, correct? So how do I get rid of that number in front? What do I do? Very good. So I'm going to factor out a negative 16, which means I'm dividing each of these terms by negative 16. And so on this one, I end up with t squared. Here, and this, just makes my life easier with a calculator. All I do is take 112 divided by 16, and I get, you can't see it very well here, 7. But specifically a negative 7t. And then I put plus my blank. I'm going to close the parenthesis. Now, if I had a number that didn't have a t, remember, we would put it outside the parenthesis. Do you guys remember that? Manvir, what's up?
Can't you take out a t? So that's
We're completing the square, so we don't want to take out a t. Okay, we want to make this a square so that we can take our vertex. Okay, so there's no number here at the end to add on after the parenthesis, but because I'm going to fill in this blank, do you guys remember what we have to have at the end? Close. Do you see right now how this is saying minus 16 times the blank? We have to have a positive 16 times the blank because we want to balance it out. Okay, and so if there's a negative in front here, there has to be a positive in front of this one, and vice versa. Okay, so this will balance our equation. Who remembers how to complete the square, what we do at this point? Very good. We take our b value, which is -7, and we divide that by 2, and what does that equal? Very good, -3.5. Do you remember what we do with that information? Okay, we square it. And so, again, this is where, like, in your calculator, this might come in handy. So if we take 3.5 and we square it, we get 12.25, because a negative times a negative is a positive, right? 12.25. And then what's next? How do I write my equation? Good. So we still have the -16 in front, and we get t minus 3.5 squared. So this factors to be this squared. Whatever our half term was, remember that's what goes in our parentheses. Okay, and then we are going to simplify this to be at the end. And so I already have 12.25 in here, so all I have to do is multiply that by 16, and I get 196. So that's plus 196. I'm going to stop there for a minute. Do we have any questions about any of those numbers at all? We're okay? All right. So if we go back to the problem, it says Kiana standing on the ground. She throws a tennis ball vertically upwards with an initial speed of this. Its height after whatever is given here. Okay, so we found all this information. So based on here, do you guys know what the vertex, what my maximum height is here? Could you give me my vertex of this equation? Okay, 3.5, 196. Do we all agree with that? So when we go to answer these questions, it says, how long does it take the ball to reach its maximum height? Very good. 3.5, and it's in terms of seconds. If you look up here, it's saying feet per second. So that's how I knew it was seconds. Okay, B says, what is the maximum height of the ball? 196 feet. And again, I know it's feet because up here it was saying feet per second. Now this question is saying, when does it hit the ground? Good. 7 seconds I heard, and that is actually correct. And I want to just talk through this a little bit. So she throws the ball, it goes up, it comes right back down, and it will end up hitting the ground. Okay? She started on the ground. These right here are your x-intercepts. Okay? Now, we could factor this right here, and if we were to factor it, we would end up getting 7 seconds. Okay? If you notice back here, and I'm just going to show you just so you can see this for other problems. So if you have h equals -16t squared plus 112t, we factor out, and we actually take out the whole GCF like you guys were saying before, and I would take out a -16t, and I'd be left with t minus 7. And then when you set those equal to 0, this one, when you take -16t equals 0, you would just get t equals 0. This one, you would get t equals 7. Okay? So it comes from your x-intercepts. Now, because she was on the ground, however long it takes to go up is the same amount of time it's going to take to go down, which is why we could go 3.5 times 2, or double it, and get 7 seconds. So when you're on the ground, it's nice. You don't have to go through this factoring process. You could double it. But there's going to be a time where someone's like standing on a building and throws something. And that will not work the same because you're throwing it up from off the ground. And so it'll take even longer to come down in order to hit the ground. Does that make sense? And so we're going to actually see that in our next example. But do we have any questions on this one before we move on? Okay. And obviously I'm taking a long time going through these because I want to make sure you guys understand. But it doesn't take as long when you're just doing the problem. Okay, so example 2, which is actually example 6 in your notes. Okay, so here we have Adrian. He throws a frisbee into the air from a building that is 99 feet tall. Okay, so I'm going to just draw a building here, or a platform. And here is Adrian, right here. Crazy hair. And he doesn't have a face, but I'll kind of give him one. Okay. He might not look like it, but he's very happy because he's standing on a building and he has a frisbee. Okay, pretty exciting. Okay, so this right here is 99 feet, is how far up he is. Okay? Now, he throws the frisbee and gets this equation. Notice how he's 99 feet above the ground, and do you guys see this 99 over here? So when you have an added piece of information here at the end that doesn't have a T with it, that is the distance up they're going. That's where like you're starting from. Okay? And so here he goes. He throws the frisbee in the air and it's going around. Again, we know this point right here is the what? The vertex and the maximum height. Okay, so in order to find out all this information down here, we need to complete the square so that we can find our vertex. Okay, so with this information here, what will I do first in order to complete the square? Very good, factor out a -3. So we're going to divide, and it's only dealing with the t's when we're completing the square. We are taking out a -3. When I do that, I'm left with t squared, and what's 24 divided by -3? Good, -8t, and then we do what? Very good, plus blank. The 99 plus 99? No. So completing the square, we're just dealing with the t part, okay? And then what else am I still missing? Plus 3 times blank. So here I actually have a -3 times this blank. And so in order to balance it out, we have to have a +3 times the blank. Okay, what do I do next to complete the square? Good. -8 divided by 2, which makes -4. At some point, and I'm going to do this different than the last problem, but remember when we got this -4 value, we would sometimes go -3 and I just write my square, the t minus 4 squared. It's up to you in the order you do this, it doesn't matter. And then what do I do to get those blank values? You square them. Okay, and -4 squared is 16. So 16 is the value that's going in each of these blanks. Okay, in order to finish up here, we need to... Very good. So 3 times 16 is what?
19.
What's 3 times 16?
Oh, 9.
Yeah, you're multiplying them. 48, good. And then we have 99 plus 48, which is 147. So I have plus 147. So here is my equation once I've completed the square, which tells me over here what is my vertex. Good. 4, 147. And again, you guys might want to put here, this is in terms of what? It didn't even, yeah, it says feet. Okay, so this is feet, or your height, right? And then down here is your time. Good. And it's time in seconds. Okay, so what is the Frisbee's maximum height? 147 feet. Okay, B, how many seconds does it take for it to reach the maximum height?
4.
Very good. Then it says, how many seconds does it take for the Frisbee to land on the ground? Now on this one, can I double 4? No. What do I have to do? We have to factor that. We have to find the x-intercepts. We have to, so we're going to have to factor this. Okay, so when I'm factoring that, what will I first take out? I'm going to rewrite it. Negative 3t squared plus 24t plus 99. So the first thing I'm going to do is factor out a negative 3. And so when I divide every term this time by negative 3, because I'm taking it as a GCF, I get t squared minus 8t minus what? 33. So on this one, we are seeing what multiplies to be negative 33 and adds to be negative 8. What numbers will work? Very good. So if you multiply those together, they multiply to be negative 33. If you add them together, they add to be negative 8. And so in terms of factoring, we would write this as t minus 11 in parentheses and t plus 3 in parentheses. And when we set these equal to 0, can negative 3 equal 0? No, doesn't make sense. Negative 3 can't equal 0. T minus 11 equals 0 will give me t equals what? 11. And over here, I would get t equals negative 3. Now, if you go back and look at this picture over here, it kind of makes sense because he's starting back here that you would have a negative x-intercept. That's dealing with the height of the building, okay? And so is the negative time actually one of my answers? No. And so the answer is 11 seconds. Yes? So when you took out the GCF here, for factoring, I took out a negative 3. So remember that this number right here is always your adding number, and this number right here is always your multiplying number. And if we had a number in front, that's where we would multiply over, you know. But the number in front right here is 1. So you can think of it as 1 times negative 33. Okay? Yes?
Why would you put the building to the left of the y-axis?
No reason, really. It really, like, this is just kind of trying to give you a visual aid of it, but all the information is actually coming from here, from the actual equation. Okay, any other questions right now? We're good? Okay, so we're going to go back to example 3 now. Okay, so example 3. The revenue R made by selling iPods at price P can be modeled by this equation. Okay, so when you're looking at this, okay, this right here on the y-axis, this is your revenue. And on your x-axis, this is your price. And if you look at your equation, you can notice that the P's are in kind of the X part of the equation that you would normally use. The R is in the Y spot because you know Y equals whatever. Okay, so again, just like the previous problems, it's asking what price will maximize the company's revenue and then what will the maximum revenue be. So it's the same thing where we're trying to figure out a maximum value. Okay, we want to figure out what is that. And the max, we know, always comes from the vertex. And so if we go to this equation, we want to do what to it? We want to complete the square. Because when we complete the square, it puts it in vertex form so that we find that maximum point. Okay. So R equals, and when we're completing the square, we just need to take out our A value. So I'm going to factor out a negative 3 over 2, which leaves me with P squared. Okay, so I'm dividing this by negative 3 over 2, so that cancels out. I'm dividing this by negative 3 over 2. What do I have to do? Close. So if you're looking at this, okay, this is really saying 300 divided by negative 3 over 2. What do we do with that problem? You do the reciprocal and change it to multiplication, right? And so this is really 300 times negative 2/3. And if you look at it like this, 3 goes into 300 how many times? 100. And then 100 times negative 2 is negative 200. So this is minus 200p. And then what do we do? Plus blank. I don't have any numbers here at the bottom or at the end, right? And then what do I still need? Plus 3 over 2 times blank. Okay, what's next to completing the square? Good. So negative 200 divided by 2 equals negative 100. It's up to you right now if you want to write your square or if you want to wait. But I know this is going to end up becoming r equals negative 3 over 2. And this would be p minus 100 squared. And then we have to square that negative 100, which makes 10,000. Okay, and so to simplify this at the end, you can think of 10,000 being over 1. So 2 goes into 10,000 5,000 times, and 3 times 5,000 is 15,000. Okay, so remember these go x and y for your vertex. And so what would be the x value of my vertex? 100. And what would be the y value? 15,000. And so it says what price will maximize the company's revenue? $100. Okay, the price is the x value, which is 100. And what is the maximum revenue that they can get? 15,000. Okay, any questions? Okay, example 4. This one is slightly different than the previous ones. This one, I think the easiest way is just to kind of set up an equation. So we're going to read through this. It says, a club sells t-shirts to raise money. They will sell 80 t-shirts if they sell them for $8 each. So looking at this equation, I'm going to kind of like write a formula, okay? So 80 t-shirts, I'm going to write that as 80t equals, they would sell 80 t-shirts for how much money? Okay, so 80 times 8, and what does that equal? $640, right? Everybody okay with that? Okay. Then it says, for every $2 increase, they sell 8 fewer shirts. Okay? So what's happening is that the shirts are going to subtract by 8. Do you guys agree? So like this value is going to subtract by 8, but this value will increase by 2. That's what they're telling me. Okay, so we want to figure out what is the best price. So I'm going to subtract 8 from 80, which makes it what? 72 t-shirts, which would be 72 times, but we're going to increase by $2, which makes that a 10. And so we multiply, and I end up getting how much? $720. Okay, so we're going to do the same thing, and see how it went up, right, in price? Okay, so 72 minus 8 will give me what? 64, right? 64 t-shirts. So that means I have 64, and then this goes up by $2, which makes it 12. And so 64 times 12 is, good, 768. Okay, we're going to keep going because my price is still increasing, right? I'm getting more money. Okay, so we're going to subtract 8 again. So what is 64 minus 8? So 56 t-shirts equals 56, but then it's going to change to 14, and in your calculator, 56 times 14 is 784. Price still increased. Okay, so we're going to subtract another 8. 56 minus 8 is 48 t-shirts. 48, this time we're going to sell them at $16. In your calculators, 48 times 16, what happens? And it went down. So this right here is our maximum. And this is the easiest way for finding this answer. So my answer would be to sell shirts for how much money? Good, for $14. That is my answer. Okay, questions? All right, we have 2 examples left. Are you ready for me to change the page? We're going to go to example 1. We're going to draw a picture. So, here we go. A rectangular pen for farm animals is made with 40 yards of fencing on 3 sides. Okay, it says the 4th side is a brick wall. So, I'm going to draw, this is going to be my brick wall. Pretty. And this is going to be my rectangular pen. Okay. And it's telling us that we have 40 yards of fencing to enclose this area right here. And so this we're going to label, these are both going to be the same length, correct? X and X. And then this side is Y. So for my perimeter, which when you're making a fence, it's just perimeter. Do you guys agree? It's going to end up being 2x plus y equals my 40 yards. Do we have any questions about that so far?
Why is there one on both sides?
Because this is a brick wall. And so the brick wall is one of the sides. And so we don't need to put any fencing on the brick wall because it's already there. And so we can use the 40 yards and the brick wall to enclose an area. Do you understand?
Not really, but...
So if you have, like if I wanted to create a barrier in this classroom, okay, and I have so much fencing or desks, all I can do is I can use this wall, like right here. This is one of the sides. You can't get through this wall. If there's a brick wall, the animals couldn't get through the brick wall. And so I'm just using the fencing to make like a rectangular area, but this is one of my sides. I don't need to use any fence on this side. So that way I can get the maximum area using the brick wall and then the fencing that I have. Does that make sense? If I just enclose with fence, then it would be a much smaller area. It's much better to use like a wall with the fencing that I have. Okay? So right here, that's why this right here, if you want to label it, that is my brick wall. So I don't have to put any fencing on that brick wall. Okay. So in order to figure out what to do here, I have 2 variables because I have two lengths, right, that are different. We have an X length and a Y length. Okay. So we are also going to use area in order to figure this out. And so if we are finding area, what would I multiply in order to get the area of inside this? X times Y. Because a rectangle, we multiply our length times our width. Is everybody good with that? So I have 2 different formulas right here for the same place. Okay? What could I do with this in order to make it so this is only one variable?
Would you subtract 2x from the side and substitute that into the other?
Exactly. If I subtract 2x here, do you guys notice how I get y equals negative 2x plus 40? So do you see how I know what y is in terms of x? So now we are taking this right here and I'm going to substitute it for y. So when I rewrite this now, I have x times, and instead of writing y, what am I going to write? Perfect. Negative 2x plus 40. Okay? and this is area equals this still, okay? And so we're going to multiply this out. We're going to distribute. I get negative 2x squared plus 40x. Now, in order to find the maximum area, okay, we are going to do the same thing that we did on our previous problems where we find our vertex by completing the square. What would I do here to complete the square? Negative 2, and we'd be left with x squared divide by negative 2, good. We get minus 20x plus our blank, and because I have a negative 2 times the blank, we need a positive 2 times the blank. Next, to complete the square, what do? Negative 20 divided by 2 makes a negative 10. And so I have negative 2, and I get x minus 10 squared, and then I actually have to square that negative 10, which makes it a 100, and then 100 goes into both those blanks, and I get plus what? 200. So, guess what the maximum area is? 200. And it's 200 yards squared. Okay, so in here, 200 yards is the maximum area you can make with having 40 yards of fencing and only using one side as the brick wall, and using one side as a brick wall. Okay, also, this is saying my x value is 10, so each of these sides are 10. And if you were to plug 10 in here for x, negative 2 times 10 is negative 20, right? Plus 40 makes 20. And see, 10, 10, 20, it makes our 40 yards that we use. Okay, example 2. Last one, we're almost done. Okay, a park is to be built on a rectangular plot of land and be enclosed by a fence, except for 6 meters wide long on one of the sides for the entrance. Okay, find the dimensions of the park with the greatest area if 138 meters of fencing is to be used. So I'm going to draw a triangle or a rectangle, just kidding, like this again. Notice I have an open space here, and that open space is going to be 6 meters. Okay. Now we still have the distance of this side is going to be y and y, and the distance of this side is going to be x and x. So I'm going to include this like as y, but then I'll end up having to subtract the 6 out. Does that kind of make sense? Yeah. So if we are talking in terms of perimeter, how would I write that equation? 2x plus 2y, but I have to subtract out 6 equals 138. Okay, my area equation is going to be what? It's still going to be just x times y. Okay, so just as we did before, we're going to solve this side for y. We want to get it so y is by itself, so we can substitute it in for y over here. Okay, so what would I do first? Good, add 6 to both sides, or if you subtract 2x, either way is fine. So I have 2x plus 2y equals, and 138 plus 6 is 144. Next, what will I do? Subtract 2x to both sides. So now I have 2y equals negative 2x plus 144. And then my last step would be to, very good, divide everything by 2. And so we get y equals negative x plus, and 144 divided by 2 is 72. Good. So now I have what y equals. And I can, just as I did before, substitute it in. So my new equation is going to be x times what? Perfect. We're going to do the same thing as we did before. Normally I'd have you do this on your own, but because of time, we're going to do this together. So we distribute. I get negative x squared plus 72x. Okay, in order to complete this square, what would I need to take out? A negative 1, because your x squared needs to be positive. And so we're dividing each of these by negative 1, and I end up with minus, good, and then what? Good, plus blank, and because I have a minus 1 times the blank, I need a plus 1 times the blank. To complete the square now, good, negative 72 divided by 2, which is negative 36. When I'm writing my equation, I get negative 1 and x minus 36 squared. So now I need to square my negative 36, and if you put that into your calculator and squared it, you get 1,296. And so 1 times 1,296 is just 1,296. And so this is my equation. So based on that, we know the maximum area is 1,296. Now they ask for the dimensions. What is the x dimension? 36. And the y dimension, if you were to put 36 in here, you would have negative 36 plus 72, which actually equals 36. Okay, so the y dimension is 36. And if you want to make sure this works out, okay, if you take 36 times 4 in your calculator, because there's 4 sides, right? 36 times 4 is 144, but then there's this 6 right here that we would subtract out because there's no fencing there, and we get to the 138 meters. So the dimensions are 36 by 36 meters. Okay, any questions?